In this video, we're going to look at one last example of solving an integral by applying U substitution first and then partial fraction decomposition. Here what we have is integral root of 1 plus e to the x dx. Our strategy would be to apply U substitution and then partial fraction decomposition. We're going to let U be equal to the whole thing, root of 1 plus e to the x. Square both sides and we get U squared is equal to, the radical disappears, we get U squared is 1 plus e to the x. Now let's solve for e to the x, and we get e to the x is equal to U squared minus 1. Now let's differentiate both sides, and we get e to the x dx is equal to 2u du. So if we solve for dx, that's going to give us dx is equal to, dividing by e to the x, that's 2u divided by e to the x du. But we already solved for e to the x in terms of u. So we have 2u divided by u squared minus 1 du. So what we have is integral root of 1 plus e to the x dx. That's equal to integral u times dx, which is in terms of u, is all of this, that's 2u, divided by u squared minus 1 du. Let's bring out the 2, so we get 2 times integral u squared divided by u squared minus 1 du. Now, clearly the degree of the numerator is 2 because u squared is a polynomial of degree 2. The degree of the denominator is also 2 because u squared minus 1 is a polynomial of degree 2. Since the degrees of the numerator and denominator are equal to each other, we have to apply long division first. But here we're going to do a shortcut that's just faster than doing a full long division. So what we have is integral root of 1 plus e to the x dx. We applied u substitution, and we transformed it to 2 times the integral u squared divided by u squared minus 1 du. So here's a shortcut. We're going to rewrite the numerator as u squared minus 1 plus 1. We haven't changed anything. Divided by u squared minus 1. So we get 2 times integral. Now we just divide it through and we get u squared minus 1 divided by u squared minus 1 plus, and 1 divided by the denominator will give us 1 over u squared minus 1 du. That gives us 2 times integral 1 du plus 2 times integral, we're also splitting off the integrals at the same time, 1 over u squared minus 1 du. Now the first integral is we can easily solve that just by reversing the power rule. So what's the antiderivative of 1? That's just u. So we get 2u plus integral 2 divided by u squared minus 1. So let's apply partial fraction decomposition to the integrand. So we have 2 divided by u squared minus 1. Let's factorize the denominator as a product of linear factors. That's 2 divided by u minus 1 times u plus 1. That's equal to a over u minus 1 plus b over u plus 1. Taking common denominator, we get u minus 1 times u plus 1. And u minus 1 times u plus 1 divided by u minus 1, multiply the result by a. So we get a times u plus 1. Similarly, we'll get b times u minus 1. So what we have shown is 2 divided by u minus 1 times u plus 1 is equal to a times u plus 1 plus b times u minus 1 divided by u minus 1 times u plus 1. The next step is to clear out the fractions and multiply both sides by u minus 1 times u plus 1, and then we will solve for a and b. Alright, so what we have is 2 over u minus 1 times u plus 1 is equal to a times u plus 1 plus b times u minus 1 divided by u minus 1 times u plus 1. We multiply both sides by the common denominator, u minus 1 times u plus 1, and we obtain 2 is equal to a times u plus 1 plus b times u minus 1. Let's plug in u is equal to negative 1. We get 2 is equal to a times negative 1 plus 1, that's 0, plus b times negative 1 minus 1 is negative 2. That gives us 2 is equal to minus 2b, divide by minus 2 both sides, and we get b is equal to minus 1. Next, we're going to plug in u is equal to 1. And we get 2 is equal to a times 1 plus 1 is 2, plus b times 1 minus 1 is 0. So we get 2 is equal to 2a, divide by 2 both sides, and we get a is equal to 1. So what we have shown is that 2 divided by u minus 1 times u plus 1, we've applied partial fraction decomposition, and we have decomposed it as 1 over u minus 1 minus 1 over u plus 1. The partial fraction decomposition has been completed. Let's put it all together. So we have integral root of 1 plus e to the x dx. We applied U substitution, and we also did long division as well. We did shortcut actually, and we get 2u plus 2 divided by u squared minus 1 du. Then we applied partial fraction decomposition to the integrand, and we got this result. All that remains is to integrate term by term. So what we have is integral root of 1 plus e to the x dx is equal to 2u plus integral 1 over u minus 1 minus 1 over u plus 1 du. So what we have is 2u plus, we're going to split off the integrals and integrate term by term. That's going to be integral 1 over u minus 1 du minus integral 1 over u plus 1 du. So that's 2u plus, what is antiderivative of 1 over u minus 1? That's just going to be, we're going to apply substitution method. We get log of u minus 1. Similarly, what is antiderivative of 1 over u plus 1? That's going to be, applying U substitution, we get log of u plus 1 plus c. Now let's substitute u is equal to root of 1 plus e to the x and get our answer in terms of x. So the result is 2 times root of 1 plus e to the x plus log of root of 1 plus e to the x minus 1 minus log of root of 1 plus e to the x plus 1 plus c. This is the answer. All right, thanks.